This groove was cut into solid granite, one of the hardest stones on Earth, by people who had never smelted a single piece of iron. And what carved it is still sitting in an Egyptian quarry today, half finished, exactly as it was left 3,000 years ago. Ancient Egypt is famous for granite obelisks, sarcophagi, and statues so precisely cut they look machined. No iron chisels have ever been found capable of scratching this stone. So what actually did the cutting? To understand the mystery, you have to understand the stone itself. Granite is a hard igneous rock, packed with quartz crystals, one of the toughest natural materials any mason could ever attempt to shape by hand. On the Mohs hardness scale, granite sits far above copper, above bronze, above almost every metal the ancient world actually possessed, quartz alone rating a 7 against copper's 3. A copper chisel struck hard against it should simply bend, not bite, the softer metal deforming long before the stone ever yields. And yet the Egyptians did not just chip at granite. They sliced it into perfectly flat slabs, drilled straight cylindrical holes clean through it, and polished its surface until it gleamed like dark glass. The place where almost all of this happened still exists, unchanged. The ancient quarries of Aswan, on the banks of the Nile in southern Egypt, source of nearly every great granite monument in the ancient world. And inside those quarries sits the single most important clue anyone has ever found, an obelisk that was never finished. It is still attached to the living bedrock, exactly where the ancient masons abandoned it. The unfinished obelisk, as it is known today, would have stood taller than any obelisk ever raised in Egypt, over 40 meters, weighing an estimated 1,200 tons. Then a crack appeared, and the project stopped forever. It was rediscovered and cleared by archaeologists in the early 20th century, and what they found stunned them. Because the crack froze the work mid-process, every tool mark around it was preserved untouched for 3 millennia. It is an open textbook, cut directly into stone. Every trench, every pounded groove, every discarded tool tells the exact story of how the work was actually done, without a single written instruction needed. So what does that textbook actually show? The first answer is deceptively simple. The Egyptians did not cut granite so much as they pounded it into submission, 1 grain of crystal at a time. Their weapon of choice was dolerite, a dense black volcanic rock even harder than granite itself, its interlocking crystal structure formed by magma cooling slowly far underground, naturally shaped into fist-sized rounded balls. There was no need for metal in this stage of the work at all. Workers gripped these dolerite balls in both hands and simply pounded the granite surface, over and over, crushing the crystal structure into powder and rubble, 1 small patch at a time, for hours on end. It sounds impossibly slow. And it was. But it worked, and thousands of dolerite pounders, worn round and smooth from use, have been found scattered across the Aswan quarry floor to this very day. Pounding could rough out a shape, and even cut a straight trench around a block. But it could never produce the razor-flat polished faces seen on Egypt's finest granite monuments. Something else was needed. That something was sand. Ordinary desert sand, rich in quartz crystal, is nearly as hard as granite itself. Rubbed against the stone with steady pressure, it becomes an abrasive that slowly wears the surface smooth. To cut long straight lines through solid granite, Egyptian masons used thin copper saws, blades far too soft to bite the stone on their own. The copper was never actually the cutting edge. It was only the carrier. Wet sand was poured directly into the cut, and the soft copper blade dragged that sand back and forth. The sand did the actual cutting. The copper simply held it and pulled. Long straights or cuts on surviving Egyptian granite blocks show faint parallel striations, exactly the signature this sand and copper method would leave behind, and exactly what a hardened steel blade never would. Flat faces and straight cuts explained much of the mystery, but granite blocks and sarcophagi also needed something harder still to produce, perfectly round, perfectly straight holes drilled deep into solid stone. For that, the Egyptians turned to tubular drills, hollow copper tubes rotated steadily under pressure by a wooden bow or a weighted crank, their diameters ranging from a few centimeters up to nearly half a meter on the largest sarcophagi, fed the entire time with the same relentless ingredient of quartz sand mixed with water. As the tube spun for hour after hour, sand trapped between the copper and the granite ground away a perfect ring, leaving a solid cylindrical core standing untouched in the center, like an apple corer working in reverse. Break that inner core free, and you are left with a smooth, straight, cylindrical hole through some of the hardest rock on the planet, using nothing but soft metal, sand, water, and rotation. Some of those discarded drill cores still survive in museum collections. Faint spiral grooves run down their sides, left by the sand grinding round and round, a fossil recording of the exact motion the tool made. For decades those spiral grooves were the strongest hard evidence archaeologists had. A tube drilling with abrasive sand, turning steadily, leaves a spiral. A tube spinning alone, without any abrasive, simply does not. Granite was not only used for obelisks and sarcophagi either. Some of the largest royal statues ever carved in Egypt, seated colossi weighing hundreds of tons, were shaped from single blocks of this same unforgiving stone. Carving a human face, with soft curves and fine detail, out of granite using only pounding and sand is a task that borders on the unbelievable. And yet dozens of these statues survive completely intact today. But evidence frozen in stone only tells you so much on its own. To really know whether a technique worked, someone eventually had to pick up dolerite, copper, and sand, and simply try it themselves. In the 20th century, Egyptologist Denis Stocks did exactly that. He spent years testing replica ancient tools directly against real granite, timing every single stroke, every grain of sand, every measured result. His copper saws, fed continuously with wet sand, cut clean through solid granite blocks at a measured rate of only a few millimeters of depth per hour of steady sawing. His tubular drills, turned by hand or by a simple wooden bow, bored perfectly clean cylindrical holes at a similarly patient pace. The ancient method genuinely worked. It was slow, brutally slow by modern factory standards. But slow is not the same thing as impossible, and ancient Egypt had something modern factories rarely have in surplus: unlimited patient labor and unlimited time. Stocks estimated that pounding a single granite sarcophagus into rough shape with dolerite alone could take weeks of continuous labor by several workers rotating in shifts. Polishing it smooth afterward could take weeks more. Drilling a deep cylindrical hole through solid granite, by hand, with sand as the only abrasive, could take hours for every few centimeters of depth. On a large sarcophagus, that time adds up to months. None of this required lasers, lost super technology, or extraterrestrial help. It required something ancient Egypt genuinely had in abundance: a centralized state able to organize thousands of skilled workers for years at a stretch. That organization is itself part of the real story here. Quarrying, transporting, and finishing a single obelisk could occupy a dedicated workforce for the better part of an entire year, coordinated like a small army. Finished granite blocks weighing dozens of tons were dragged on wooden sledges, the ground ahead of them lubricated with wetted sand to cut friction by roughly half, a technique preserved in tomb paintings showing teams of men hauling colossal statues this exact way, down to barges waiting patiently on the Nile. From there, the river current carried monuments weighing hundreds of tons downstream to temples and tomb complexes across all of Egypt, a transport network built entirely on human coordination and the Nile itself. So the pieces were falling steadily into place: the hardness problem, the pounding, the sand, the copper, the drilling, the transport. But one specific claim still needed testing directly against the tools themselves. Could ordinary Egyptian copper, with no special hardening trick at all, actually survive the abuse of cutting granite, or did the masons secretly rely on some lost metallurgical process we still haven't rediscovered? Metallurgical analysis of surviving copper tools found no secret alloy, no trace of tin bronze, and no hidden hardening process whatsoever, just the same soft arsenical copper used for ordinary household tools across ancient Egypt. The copper was completely ordinary. It was never meant to be the cutting edge on its own. It only ever carried the sand that did the real work. That single fact quietly answers the loudest objection skeptics raise. Soft copper against hard granite sounds like a contradiction. It never actually was one. It was always copper plus sand plus water plus time, for completely ordinary ingredients that ancient Egypt had in unlimited supply, working together against a stone that could not resist all four at once. And the proof that it genuinely worked is not locked away in a laboratory somewhere. It is standing in major cities across the modern world, in broad daylight, for anyone at all to walk up and touch. Egyptian granite obelisks were relocated to Rome, Paris, London, and New York centuries after they were first carved, and every single one of them still bears the same tool marks first cut beside the Nile. The obelisk now standing in New York Central Park, nicknamed Cleopatra's Needle, carries the exact same pounded and polished granite surface it was given in Heliopolis nearly 35 centuries ago. The obelisk standing in Paris on the Place de la Concorde once stood at the entrance of the Temple of Luxor, and its granite surface has now weathered two very different climates across 200 years. Granite sarcophagi from the Old and Middle Kingdoms, some polished to an almost mirror finish, sit today in museum halls, their flat faces and sharp interior corners exactly matching what sand and copper alone can achieve. None of this diminishes the achievement in the slightest. If anything, it makes the achievement larger because it means ordinary people, not lost gods or vanished machines, accomplished something this precise using patience alone. It is worth pausing here on why the alternative theories took hold at all, because the instinct behind them is not really a foolish one. The precision genuinely is startling to look at with cold eyes. Flat faces true to within a fraction of a millimeter. Drill holes so perfectly round they look turned on a modern lathe. It is easy to see why some people reach for lasers and lost civilizations. That instinct was amplified in the mid-20th century by a wave of popular books arguing ancient monuments were built with the help of extraterrestrial visitors, a claim that spread far faster than the actual archaeology. Those books rarely engaged with the tool marks themselves, the spiral grooves, the saw striations, the thousands of discarded dolerite balls. They preferred the mystery to the evidence, because the mystery sold more copies. But precision is not the same thing as impossibility, and every single result attributed to secret technology has now been reproduced, by hand, using only materials that genuinely existed in ancient Egypt. That reproduction is the difference between a genuine unsolved mystery and a mystery that has already quietly been solved. A real mystery has no working explanation. This one now has several, tested and repeated. Ancient graffiti and quarry marks scratched onto the bedrock near the Unfinished Obelisk even record the work gang's own names and progress notes, ordinary administrative marks left by ordinary organized labor, not by gods. Even the crack that killed this particular obelisk is itself geologically ordinary, a natural flaw hidden inside the granite that no amount of skill could have detected in advance, hidden until it was already too late. The quarry today draws visitors from around the world who come specifically to stand beside the crack, to run their hands across the pounded trench, and to see for themselves how the story actually ends. So return to that obelisk, still lying in its quarry bed today, still cracked, still unfinished after more than 3,000 years, exactly the way its exhausted builders left it the moment the fracture appeared. It was never a monument to failure. It is a monument to method. Every trench beside it, every pounded groove, every abandoned dolerite ball scattered nearby, is a frozen snapshot of a technique that took the hardest common stone on Earth and simply made it obey. Egypt's granite achievement stands alongside other ancient stoneworking feats across the world, each culture solving the same basic problem: hard stone against soft tools, in its own patient and independent way. What sets Egypt apart is simply how much survives: the quarry, the abandoned obelisk, the discarded tools, the drill cores, laid out together like a complete instruction manual nobody ever needed to write down. Modern quarrying, by comparison, relies on diamond-tipped saws, hydraulic splitters, and steel drills spinning at thousands of rotations a minute. It is worth remembering that none of that existed for the vast majority of human history. Every civilization that ever worked hard stone before the Industrial Age faced this exact same wall. How do you cut something harder than every tool you own? Egypt's answer, patience multiplied by sand, was simply the most complete one that survives. And it worked well enough that some of these granite monuments have already outlasted every empire that came after the one that carved them, standing through conquest, flood, earthquake, and 3,000 years of desert wind. Now think back to that groove from the very start of this film, the one still sitting in the Aswan quarry, its tool marks completely untouched since the day the ancient work suddenly stopped. That groove was never cut by lost technology, by aliens, or by tools history has forgotten. It was cut by dolerite hammerstones, copper blades, quartz sand, river water, and years of patient human labor. For ordinary ingredients. No secret alloy. No forgotten machine. Just people who understood their materials completely, and who were willing to spend months on a single stone until that stone finally obeyed them. That is the real answer to how Egypt cut the hardest common stone on the planet without a single piece of iron. Not a mystery. A method. Patient. Ordinary. And utterly, entirely human.